Hi friends, welcome to CAT Engineers Academy online platform. Today we will discuss how to analyze electrical circuit problem by using maximum power transfer theorem. It's nothing but simply they will ask when the maximum power will transfer and what is the maximum power delivered to the load resistance. Like that we will get the problems in electrical circuits. Now we have to see how to analyze that circuits by using maximum power transfer theorem. Okay friends, let's we consider one problem, then we have to analyze. See, here we consider one problem. What is the problem is find the value of RF. Simply they are asking what is the load resistance for maximum power transfer. It's nothing but whenever the maximum power will transfer, what is the load resistance for the following circuit, find maximum power also. So finally they are asking what is the load resistance as well as what is the maximum power delivered to the load resistance. Simply they are given one circuit is consisting of 12 volts, 6 ohms, 12 ohms, 3 ohms, 2 amps and 2 ohms resistor and load resistor. Okay friends, so finally here we need to determine what is load resistor and what is the maximum power delivered to the load resistor. Okay friends, just listen. Maximum power transfer theorem is nothing but when the maximum power delivered is when RL equal to RTH. So finally we need to determine RTH. Finally that RTH is nothing but load resistor only. Okay friends. So it is indirectly nothing but just like a Thevenin's theorem only. How we have to analyze the problem by using Thevenin's theorem. Like that only we have to solve the problem. It's nothing but it is a repetition of Thevenin's theorem problem only. Okay, how they are asking that how they are solving the problem in Thevenin's theorem, same like that here also solve the problem. Finally you have to determine the RTH. That RTH is nothing but RL. In order to develop the maximum power we have to know what is the VTH, because P max equal to V square TH by RTH 4 RTH. Okay, by using that formula we have to determine the solution. Okay friends, now finally not only RTH, V square by 4 RL also correct. If you are substituting RL equal to RTH, you will get the formula in terms of RTH. If you will substitute RL, you will get the directly answer RL. Okay, finally, first we have to determine the Thevenin's resistance. So first find Thevenin resistance. First you have to find the Thevenin's resistance. So first find Thevenin's resistance. So what is the rule in order to calculate the Thevenin's resistance? Just listen. Wherever they are asking the problem, for example they are asking the problem, this is A and B is the load resistance. Now how to calculate the Thevenin's resistance? In between these two terms you have to calculate the Thevenin's resistance. Just you have to open the load resistance and calculate the what is the equivalent resistance in between A and B. That is nothing but only RTH. In order to calculate the equivalent resistance, while you are calculating the RTH, you have to replace the sources by their internal resistance. Nothing but voltage source you have to make it as a short circuit, current source you have to make it as a open circuit. So like that you have to draw the circuit. Finally you have to calculate the RTH. So voltage source is nothing but you have to make it as a short circuit. Now finally here we are having the 6 ohms. Next here we are having the 12 ohms. Okay. Next here we are having the 3 ohms. Next here we are having the current source, you have to open it. Next here we are having the 2 ohms. Next here A, B, here load resistance you have to open it. Next here you have to calculate the RTH, equal resistance only RTH. So finally this is 6 ohms, this is 12 ohms, 3 ohms and 2 ohms already given. So finally you have to calculate what is the equivalent resistance in between the A and B. So this is equivalent resistance is nothing but, just listen, here this is open is nothing but 3 ohms and 2 ohms are connected in series, and this series combination is connected in series with the parallel combination of 6 and 12. So finally directly here I am writing the equation. RTH is 3 and 2 are connected in series, so 3 plus 2. This combination is in series with the 6 in parallel with the 12. So finally answer is 5 plus 6 into 12 by 6 plus 12. Now final answer is, that answer is RTH equal to 9 ohm. So finally from this we can say that, from this RTH one we can say that load resistance, they are asking load resistance. So first question is over. Load resistance RL equal to RTH equal to 9 ohm. So first question is over. Next they are asking what is the maximum power also. So in order to find out the maximum power, the formula is, the maximum power formula P equal V square TH by 4 RL or V square TH by 4 RTH. So finally in order to evaluate the maximum power we have to calculate the VTH also. Okay, next question is to find Thevenin's voltage. To find Thevenin's voltage. Find Thevenin's voltage. So that is VTH. So finally calculate the VTH. Then how to calculate the VTH is nothing but just wherever we are having the load resistor, just you have to remember it, and in between these two terminals you have to calculate the voltage across A and B by considering as this circuit. Now finally once again you have to redraw the circuit in order to calculate the VTH. So that is, first we are having one resistor, next this is one more resistor, next here we are having one source. The source is 12 volts, here this is 6 ohms, this is 12 ohms, next this is 3 ohms, next this is 2 amps, next this is 2 ohms, next you have to open the load resistor, then this is A, this is B. Now in between these two terminals you have to calculate the voltage drop, that voltage drop only VTH. Now in this circuit we have to find out the VTH. Now how here I am calculating VTH is nothing but by using mesh analysis. Just listen once again, here we are repeating mesh analysis also. Now in this problem you will learn the mesh analysis. So mesh analysis is nothing but first you have to identify the loops. So how many loops you are having? This is one loop, this is second loop, this is not a loop because it is to be open. Open is nothing but this 2 ohms is not connected in this part. The current flowing through the 2 ohms is 0. So finally this is not a loop. So finally determine the VTH by using mesh analysis. Here I am determining. So determine VTH by using mesh analysis. So mesh analysis is nothing but first step is you have to identify the loops. So how many loops we are having? 2 loops. Then assign the loop current. So finally here I am assigning the loop currents. So this is I consider as one loop. Now this I consider as a small I1. Next one here I consider this one as second loop. This is I2. Now this is not a loop, so there is no need to assume the current direction. So finally we are having the 2 loops. So in that small I1, in that small I2. Now write KVL equations. Now apply KVL to loop or mesh to first. Whether to mesh 1. This is the mesh 1, this is the mesh 2. So KVL here is nothing but how many elements we are having? 2 elements and 1 source. So here rise in potential you have to consider as a negative, minus 12. Next 6 ohms is plus, here minus. So drop in potential you have to consider positive. So 6 I1. Next 12 is going to be in between the first loop and second loop. So both the currents are flowing in the 12 ohms. So finally we can consider the resultant current. With respect to first loop, we are writing the equation. You have to consider I1 minus I2 because I1 is downward and I2 is upward. So finally I1 is downward, I2 is upward. So I1 minus I2. So plus 12 into I1 minus I2 equal to 0. I1 minus I2 equal to 0. So finally we get the equation minus 12 plus I1 is nothing but 18 I1 minus 12 I2 equal to 0. Now you take the 12 final equation is 18 I1 minus 12 I2 equal to 12. Now you consider this one as a first equation. Now you consider this one as first equation. Okay. Now this first equation is 18I1 minus 12I2 equal to 12. Next you go for the second. Then apply KVL to loop or mesh to second. So now finally next second loop. For the second loop, just to go for the second loop, 12 3 2 amps. So final, just listen, in this loop directly we are having one current source. So finally we can consider directly this value as I2 only, but it is opposite direction. Now finally from this we'll get the I2 equal to minus 2 amps, minus 2 amps. So finally directly we'll get the I2 current. Now substitute second equation in first equation. In first equation are evaluate the I1 because directly I2 is evaluated. There is no need to simplify these two equations. Directly we'll get the equation. So finally after substituting we will get the answer is 18 I1 minus 12 into minus 2 equal to 12. So 12 to the 24. Right side with this. So finally we get the I1 equal to minus 24 minus 24. So finally we get the minus 12 by 18. So finally answer is minus 12 by 3. So finally minus 2 by 3 answer is. So finally I1 I2 is evaluated. Then you go for the VTH. How we have to evaluate the VTH is, just listen. Here in our circuit VTH is drop across A and B. So drop across A and B is nothing but indirectly here this is loss. So finally just to write the KVL equation for the outer loop. KVL equation for the outer loop, finally we get the VTH. Okay, finally apply KVL around the outer loop to get VTH across terminals A to B. Now finally across around the loop, outer loop is nothing but this is the outer loop. So outer loop is this here. This is the outer loop. So now finally this is outer loop. Now this, for this outer loop we have to write the equation. Okay friends, now finally that outer loop equation is, just listen, 12 6 3. So minus 12 plus 6 into I1 plus 3 into I1, there is no current in 2 ohms, so 0. So plus VTH equal to 0. So finally the equation is minus 12 plus 6 I1 next plus 3 I2 plus 2 into, there is no current in this, 0 plus VTH equal to 0. Outer terminal between A B is plus VTH. So finally from this we'll get the VTH equal to 12 minus 6 into I1. I1 is nothing but minus 2 by 3 minus 3 into I2. I2 is how much? We get the I2 is minus 2 amps. I2 is minus 2 amps. So minus 2. Next 3y plus 12i over 6 over finally. So finally 3 into minus 2. So VTH equal to 12. 3 2 just so plus 4 and plus 6. So finally answer is 22 volts. So finally VTH equal to 22 volts. VTH equal to 22 volts. So finally friends, VTH is over and RTH RL is also over. So final question is we need to determine the maximum power. So the maximum power is maximum power is the maximum power is P max equal to formula P max equal to V square TH by 4 RL. V square TH by 4 RL or V square TH by 4 RTH. No problem because RTH equal to R. So finally VTH is 22 square by 4 RTH. So 4 into 9. So finally answer is P max equal to 13.44 watts. Now finally this is the P max. Okay friends. So finally by using maximum power analysis we determine what is the load resistor as well as what is the P max. Okay friends. So like that we have to solve the problem by using maximum power transfer theorem. Okay friends, just watch the video step by step. Don't miss. Every step is very important to get the final solution. Okay friends, if you will watch the video first time, please like, share and subscribe our channel. Okay friends, we will meet in the next video. Thank you. Bye.